we have seen closed loop transfer function and open loop transfer function. Now, if we consider a unity feedback system where the Laplace transform of feedback system is equal to 1, then our open loop transfer function will become Laplace transform of feed-forward system, and the closed loop transfer function will become Laplace transform of feed-forward system divided by 1 plus Laplace transform of feed-forward system. But we also know the Laplace transform of feed-forward system is equal to open loop transfer function. Then we can also write closed loop transfer function is equal to open loop transfer function divided by 1 plus open loop transfer function. Now if we assume the open loop transfer function in the form of numerator and denominator, the closed loop transfer function will then come out to be equal to numerator divided by denominator plus numerator. Now consider the reverse case where we are having closed loop transfer function and we are supposed to find the open loop transfer function. If we rearrange the earlier found equation, then we can also write open loop transfer function is equal to closed loop transfer function divided by 1 minus closed loop transfer function. If we assume the closed loop transfer function is written in the form of numerator and denominator, then the open loop transfer function will come out numerator divided by denominator minus numerator. These are the formulas which are widely used even though they are very simple. But keep in mind all the formulas which are shown in front of you are meant only for unity feedback system. Now quickly come to our next topic, which is type, order and DC gain of the system. I have taken a system with the shown transfer function, but we already know there are two types of control system, and depending upon the type of system, we will proceed how to find the type and order of the system. So let's consider two cases. One is open loop control system and the other is closed loop control system. If we talk about open loop control system, then we know we only have one type of transfer function in that system, which is referred as open system transfer function. But when we talk about closed loop control system, we have closed loop transfer function as well as open loop transfer function, and the closed loop transfer function is equal to the transfer function of the system. If we assume the unity feedback system for simplicity, then we can also find the open loop transfer function to be equal to s plus 2 divided by s square into s plus 1. We have simply used the formula which we have just discussed, where we have assumed the closed loop transfer function is written in the form of numerator and denominator, and the open loop transfer function will then be equal to numerator divided by denominator minus numerator. Open system transfer function of open loop control system and open loop transfer function confuses a lot of students. But it should be very clear to you that even though their names are quite similar, but still they are very different things. Order is defined as a total number of poles in the system's transfer function, and we can find the order by simply checking the highest power of the Laplace variable s in the characteristic equation. The denominator in the system's transfer function is referred as the characteristic equation of the system. Since the transfer function in both the cases are same, therefore the order is 3 in both the cases. It is quite strange that the same word may mean different things in different subjects. You might have heard the word order in mathematics also, particularly in linear differential equations, where the meaning of order is slightly different. Here we are studying type and order. In mathematics we study order and degree. The shown equation is an example of differential equation of order 3 and degree 1. The highest derivative of the variable is referred as the order, whereas the power to which the highest derivative is raised is referred as degree. The same word may have different meanings in different subjects. That's why these are the topics which confuses the students the most. While writing exams, you will be having your own library in your brain while you act as a librarian. There are different concepts from different subjects, and if you don't know which book is kept in which part of your brain, then it will simply consume a lot of your time to solve a problem. If any question regarding order comes and you are searching in the wrong section of your brain, let's say mathematics, but the question is of control systems, then you will simply waste a lot of your time in recalling the exact concept by using which you are supposed to solve the problem. That is the reason why I usually discuss these type of points which creates confusion, particularly in competitive exams where you have to remember so many subjects all at once. Now see what is the meaning of type of the system. It represents the number of poles at the origin. You have to remember this point that for closed loop control systems, type is defined only with the help of open loop transfer function. However, for open loop control system, it is quite straightforward as we are having only one type of transfer function for open loop control system. So, for open loop control system, the type will be 0, whereas for the closed loop control system, the type of the system is 2. The another term is DC gain, which can be easily calculated by putting the limiting value of s tends to 0 after removing the poles at origin. The term s raised to the power p represents the factor which is meant for removing the poles at origin. Like for the above considered transfer function, we have 3 poles at origin, therefore we will multiply the transfer function with s raised to the power 3, and after cancelling the poles at origin, we have to simply put the value of s equal to 0 and calculate, which will come out to be equal to 2 upon 81. Therefore, the DC gain of the system is 2 divided by 81. You can clearly see that it is not a very lengthy or difficult procedure to calculate the DC gain, but it does not mean that you will be finding the DC gain of any system blindly. The thing is, you can find the DC gain of only stable systems. We cannot calculate DC gain for unstable systems. For now, just write this transfer function s upon s minus 1 as an example. Laterwards, after 2-3 lectures, it will become very easy for you to determine whether the system with provided transfer function is stable or not. Majority of the times, you can simply put the value of s equal to 0 in the expression after removing the poles at origin, but some tricky questions can also come, particularly in competitive exams, where you have to use a little bit knowledge of mathematics also, like the L'Hopital's rule, which is used for finding limits of the expressions which are in the form of 0 by 0 or infinity by infinity. So, few topics of mathematics can also be combined here to form some tricky questions. There is one more important point. In control systems, we can have 3 different types of transfer function: strictly proper transfer function, proper transfer function, and improper transfer function. These classifications are fine theoretically, but when we deal with control systems practically, we always assume that we are dealing with complete transfer functions only. Complete transfer functions are the transfer functions where the number of poles are exactly equal to the number of zeros. For reference, consider an example with transfer function as shown. Students will generally say the transfer function is having 1 0 and 3 poles, but it is not true. If such conditions arises, then you will say that we are having 3 zeros and 3 poles. The other 2 zeros are assumed to be at infinity. The same will happen if we are having 1 pole and 3 zeros. Then also we would say that the system is having 3 zeros and 3 poles. In that condition, we will have assumed other 2 poles are at infinity. One very important point you have to keep in mind is that type of a control system is defined by the open loop transfer function of unity feedback systems only. If we have to find the type of non-unity feedback system, then we first have to convert the system into unity feedback system, and then only we can find the type of the system. It is quite easy to convert a non-unity feedback system into a unity feedback system. Let us consider a non-unity feedback system with feedback function Hs. Now, we have to simply introduce 2 more feedback paths which are negatively feeded to the comparator. One is having feedback function of -1 and the other one is having the feedback function of 1. In the later lectures, you are going to know more rules about the deduction of block diagrams, but here just remember that if there are 2 parallel branches with the data flowing in the same direction, then we have to add their individual gains to find the resulting gain of the system. Here, the 2 introduced feedback paths with gains -1 and 1, when we add them, we will get 0, which simply means that it does not affect our original system. After that, we have to solve the block diagram leaving only one unity feedback path. After solving, you will get the modified feed forward transfer function to be equal to original feed forward function divided by 1 plus feed forward function multiplied by feedback function minus 1. You have to use this method to find the type of non-unity feedback system. Try to solve a question. For the given transfer function, we can easily find the order of the system, which will come out to be equal to 4. But again, if we have to find the type of the control system, then we have to first convert it into a unity feedback system, as the provided control system is a non-unity feedback system. First, we will add two feedback paths with gains -1 and 1. To avoid confusion, I am expanding this block diagram in terms of 3 separate summing points, which is actually the same, and will solve one by one so that you don't get confused. First, the transfer function of the block diagram is provided in the question itself. Then we actually don't need to solve this part of the block diagram, as when we solve this particular part, which is present inside red dashed rectangle, it will actually be equal to the transfer function. After substituting the value of transfer function in this block diagram, we will then solve the block diagram, which consists of transfer function and a negative unity feedback path. After solving which, we will get this resultant block diagram. Now, this is the same system provided in the question, but is represented in a form of unity feedback system. Now we can easily find the type of the system, which will come out to be equal to 0, as there are no poles at origin of the open loop transfer function in this unity feedback system.